Good morning, everyone. We're going to get started here now. So hopefully everyone can see my screen. My name is Denise Shannon. I'm a program manager here at Rancher. I'm joined today with Josh. Josh, do you want to say hi?
Yep, sure. Hey, everyone.
Today we will be going over a technical introduction of using Kubernetes on Rancher. We have a couple of slides, a little more than our typical training, but we'll mostly be trying to demo. And then the biggest thing is, if you have questions, we want to be able to answer them for you. So on the side of your GoToWebinar section, there's a little question side. We have a couple of people on the line here today to help us answer your questions. I'll be monitoring the questions myself when Josh is demoing to see if there's anything specific that we should talk about or elaborate more in person. And then just like all of our webinars and meetups, if you have questions, we will try our best to answer them until the end. I know we're scheduled for an hour. I'm not quite clear how long it's going to take, so we'll always stay and answer as many questions as we can until the end. So for this training, for today's training, we kind of have the assumption that you already kind of know Docker. You're trying to look and understand actually Kubernetes. We do also assume that you have at least a little bit of basic Rancher knowledge if you've never used Rancher. I'm not going to go over how to set it up or anything. I'm going to mostly concentrate on how you set up Kubernetes itself. So if you want to learn more about Rancher, we will be running an Intro to Rancher training Thursday, June 8th. You can go register at rancher.com/training. And then before we get started, there are more resources that, if you are new to Kubernetes, new to Rancher, that you can use to help get you started. There is our doc site. This here specifically is a link to Kubernetes itself. We have our forums. Our community is really active in helping answering questions. And then also we do have on GitHub, you can file issues if you find bugs. So today's key topics, I'm going to go through setting up Rancher. I'm going to deploy Kubernetes on Rancher. And then I'm going to hand it off to Josh, and he'll be basically covering over Kubernetes concepts, setting up kube control, and launching these Kubernetes items that exist. So just a little quick background about Rancher and Kubernetes. One of the great things is that it's really a one-click deploy to get Kubernetes up and running in your Rancher setup. So once you have Rancher running, all you have to do is, I'll go through it today. You just set up Kubernetes, you launch it, you wait for basically your infrastructure stacks to get up and going, and then you can start immediately go into Kubernetes and start doing things in there. So I'm going to get out of my slides real quick, and we're going to start to demo. So the only things I've done before the demo is I've set up two AWS boxes. They are running Rancher OS. They are running Docker version 1.12.6 because Kubernetes itself doesn't support Docker 1.13 or above yet. And then I have one box that you can see that I already have started. I've started Rancher Server. It's just a plain vanilla install. And then I have another box that all I've done is pre-pull the images that we'll be using in our demo today. And the only reason why I do that is just to make the demo go a little bit faster so we don't have to actually wait for these images to pull down. So you can see I have Rancher setting up. For those who have never used Rancher, you just go to the IP of your host that you have. You go to port 8080. That's where it's exposed. That's where I exposed it in my Docker run command. And you'll be prompted here to this lovely welcome to Rancher sign. You'll notice that there's a little checkbox that says allow collection of anonymous stats. That really helps us understand what our users are using, if they're using which container orchestration are you using, if you're using Kubernetes or not, and which type of hosts that you're using. It really just helps us figure out where we should concentrate our development efforts. So I'm actually going to uncheck this because they don't really care about what I'm doing. We care more about what you're doing. You can see once you come in, I have no hosts. I'm in this, what we call a default environment. I'm going to go to the Manage Environments page. Under here, we have what we call an environment template. When you start Rancher, you get a couple of these by default. Here you can see a default Kubernetes environment template. I'm actually going to edit it just to show you what it exists. So what it does is it has a couple infrastructure services that are going to be required in order for Kubernetes to get set up. And then you pick your container orchestration. Here you can actually edit the configuration of your Kubernetes. So if you had if we had different Kubernetes versions available for your Rancher server version, this is here where you could pick and select which one it would be. Outside of that, there are a bunch of configuration options in terms of how you could configure your Kubernetes setup. A lot of this is actually covered in our docs under Kubernetes. I'm not going to go over what all those options are today. It's really, the default is set up more for a development, just like if you're playing around with it. So if you wanted to, after you've played around with it and tried it out, and you wanted to move into production, you probably want to look at these configuration options, figure out what's the best setup for you, and then launch Kubernetes that way. So let me cancel out of that, and then I'm going to cancel out of editing my template. And then I'm going to add a new environment called Kubernetes, and I'm going to create it. So here, you can see right now we go into the Kubernetes environment, and it's waiting for me to at least add one host. So I'm going to go to the host. I'm going to add a host. I'm going to save. So there are a bunch of options. Like I said before, I'm not going to cover what they are. I'm just going to take our custom option because I already have a box running. I'm going to go to that host, and I'm going to add a host to my setup. Because I pre-pulled all the images, it should come up pretty quickly. And everything should get started. If I go here to our infrastructure stacks for Kubernetes, you will see that I have my basic, there are a couple of basic infrastructure stacks that are needed to get networking working for Rancher so that you could communicate across hosts. And then we have our Kubernetes stack that's going to start going as well. While that gets going, I am just going to turn on what's called access control, just authentication, just so that no one out there will be able to maliciously try and mess around with my demo. I'm going to turn that on. While that goes on, I'm going to add Josh as a user or as an admin. And then I'm going to, right now I've added Josh as a user, so he has access to Rancher, but he actually won't be able to get into Kubernetes, so I'm going to just add him to the environment so that he will be able to see the Kubernetes environment. So it looks like Kubernetes is up and running. You can see everything's green. That's good. And then I think that's it. So I'm actually going to hand it off to Josh so that he can start talking about the concepts in Kubernetes before we start demoing it. Let me just, sorry about that. Get to that page. There you go.
Okay, so the first thing I'm going to discuss is the concept of a pod. This is something that's kind of confusing for new Kubernetes users because most people expect that when you're using a container orchestration system that you should be able to go in and just start launching containers. That's not actually the case with Kubernetes though. So the smallest unit that can be deployed to Kubernetes is actually a pod. So a pod is one or more containers that are tightly coupled in various ways. So these containers are always going to be scheduled on the same hosts, and each of the containers within the pod are also going to be in the same network namespace, which means like each container within the pod can communicate with another container just via localhost. And also each pod is given a unique IP address. So these are like the pods can talk to any other pod in your cluster just through this IP address. But the ideas of pods to new users, they're not like very useful at the start. They're a very powerful construct that you can use later on. But if this is too confusing for you and you're not really sure like why I would use this, like what the use cases of it are. Just don't worry about it too much for now. Just try to think of a pod as a single container. So in most cases, each pod you run is only going to be running one container inside of it anyway. So just try to think of like the abstraction of a container and pod as being the same, especially for this demo. Okay. Can you transfer?
Okay.
So now I'm just going to do a couple of quick demos around pods. Okay. So I'm going to go back to the Rancher setup that Denise set up earlier, and I'm just going to log in. So as we said earlier, we already have Kubernetes all set up. So what I'm going to be doing for like the remainder of the demos is demoing a utility called kubecontrol. So this is the main CLI for interacting with the Kubernetes cluster. So when you're in the Rancher UI, if you go to Kubernetes CLI, there are two ways that you can actually interact with kubecontrol. So one of them is a built-in shell that you can actually access through the browser itself. So we can see that we can do basic kubecontrol commands here, like let's say we want to show all nodes that are in the cluster currently. So we can do kubecontrol get node, and that'll list just all of the nodes that are in the cluster. So for the rest of the demo, I'm actually going to be using it in my local terminal. So when I click generate config, it's going to give me a configuration file that I can use to talk to the Kubernetes server. So this just contains information like the IP address of the endpoint and some authentication, so that kubecontrol is able to access the Kubernetes cluster externally. So this file goes in the home directory under .kube config. So I already have one here. I'll just delete this and then insert the current one. Okay. So now I should be able to do kubecontrol get node from here and see the same hosts. Okay. So now I'm actually going to show deploying a pod to this cluster. So the first one I'm going to deploy is just a simple shell. The command is just sleep infinity so that it stays alive, just something I can use to exec into later to show the perspective of the Kubernetes cluster from inside a pod itself. So some basic information about this file. It's in YAML format, and it's a pretty standard Kubernetes resource file. So like a lot of the stuff in here is just boilerplate. So the metadata name, you're going to see this on all resources within Kubernetes. And then under here, this describes like the things that are inside the pod itself. So in this case, we're running only a single container. The image is something I've pre-made that just has some utilities we can use later on the demo to show various things. And then the command is sleep infinity. So to actually like take this Kubernetes manifest and launch this to the cluster, I can use the kubecontrol create command. So this just takes a Kubernetes resource and it deploys whatever contents are in it to the Kubernetes server. So if we do kubecontrol create -f shell pod, we can see that the pod was actually created. And now we can do another kubecontrol get command, kubecontrol get pod, and then it'll show you all the pods that are currently running in this namespace. So in a separate tab, I'm actually going to do kubecontrol exec. So I'm actually going to run a shell inside of this pod. So this is just like allows us to see the other pods in the cluster just from like the perspective of something inside of it. So next I'm going to launch another pod. In this case, it's just a pretty simple Nginx pod. And then I'm going to expose this on port 80. So I'm going to do kubecontrol create on this pod as well. And then we should be able to see both of these pods running. So the reason I started the Nginx was just to show the concept that all pods can talk to each other within the same cluster. So if I go back to the shell that I was in earlier, I should be able to, or sorry, actually, first I'm going to grab the IP address of this pod. So another command we can use to do this is the kubecontrol describe command. So if we do kubecontrol describe pod and then the name of the pod, it shows us various information about it. In this case, all I'm going to do is just grab the IP address. All right, so going back to the shell, I'm just going to curl this IP address and see what happens. Okay, so we can see that this pod was able to talk to another pod. And this is just like curling Nginx on port 80, and this is the default configuration that you get whenever you run Nginx. So I just want to go back to the host itself. So in this tab, I'm SSH'd into the host that Denise set up earlier. So I just want to show you that something actually is happening behind the scenes, like on the host itself. So I'm going to do docker ps grep nginx. So this is just listing all containers that are currently running, and I'm looking for ones that contain the string nginx. Sorry, I think I've been SSH'd into the wrong host.
You probably need to grab, are you SSH'd into the server?
Oh yeah, sorry, this is the wrong host. I want to be on the worker node and not the master node.
So we have two hosts. Usually we recommend where you have one that's running for your Rancher server container, and then you have one that's added into Rancher as a Rancher agent.
Okay, so let's try this docker ps command again. Okay, so you can see that there are two containers that are currently running. One of them is just a plain nginx container, and this is the one that was created when we launched the pod. And then the other one, which still contains the string nginx, is just a container that Kubernetes will launch just to manage pods. So for each pod that you launch, you'll see that there's an additional pod called, or container called a pods container. And this is just something that Kubernetes uses internally to keep track of pods. Okay. Lastly, I just want to show a third option for pods. So I'm not actually going to launch this, but I just want to show that there's like various other options that you can actually do when you're deploying a pod. So for those of you that are familiar with like the Docker run command or Docker compose, a lot of the same flags that you'll see there can also be exposed when you're launching pods. So things like creating environment variables, mounting files from the host into the container, you know, scheduling rules where you only want to deploy to certain nodes in the cluster, or control like host networking, host IP, and like that type of stuff. Okay, let's go back to the slides. So when you're using Kubernetes, you're not actually going to launch pods directly very often. The life cycle of a pod is actually mortal, which means if you deploy a pod to the cluster, let's say it lands on a host, and then later on that host goes down, Kubernetes isn't actually going to bring up that pod on a different host. So it's something to get that kind of functionality, what you would use is a deployment.
Oh, I grabbed it.
Oh, okay. So yeah, a deployment is what you would actually use when you want to launch pods to a Kubernetes cluster. So I think it's usually just for demo purposes that people will launch a pod directly. So deployments are a level of abstraction above pods and allows you to define their desired state in a declarative way. So for example, like if you're launching a pod and you want it to have scale 5, you would launch that as a deployment, and then Kubernetes would ensure that 5 instances of that pod are always up across the cluster. Okay, now I'm going to show some demos of deployments. I guess before I do this demo, does anybody have any questions so far about just the ideas of pods or basically launching these?
I've been scanning through the questions. It doesn't look like there's any specific. There were some questions, but I think the team that we have helping to answer questions have been answering them. There's nothing that I've seen, I think.
I'll ask later on. So I'll move on to deployments and doing this demo. Okay, so the first deployment I'm going to launch is actually pretty similar to the pod that I launched earlier, and it's just going to be a pretty basic nginx deployment. So like the only thing that's different here, you'll see that the kind is different. So we're launching a deployment instead of a pod. The metadata name is still the same. You'll see that under spec, we're going to have a number of replicas. So in this case, we're going to be launching 3 nginx pods. So once we launch this deployment, we're going to see Kubernetes bringing up these 3 pods. So we do add a label to this. This is something I'll come back to later when we talk about services. And then under the pod spec, we see we have basically the same container as last time. I just attached a version number or version to the nginx container. Okay, so I'm going to do kubectl creates for this nginx deployment. So like I was saying earlier, kubectl is a pretty generic command. It's actually going to create like whatever resources in the file itself. So it's not exclusive to launching pods or launching deployments. It can launch any kind of resource that you can put in a Kubernetes manifest. Okay, so we can see that the deployment was created. So if we do kubectl get deployment, we should be able to see the deployment that was just launched. So now if you go back and we do kubectl get pods, we can see that Kubernetes brought up 3 instances of the Nginx pods. So these 3 here are the ones that are being managed by the deployment. So you can see that Kubernetes is attaching a unique hash at the end of it. Okay, so like I was saying earlier, this deployment defines like the desired state of your cluster. So if for any reason the actual state does not match the desired state, Kubernetes is going to make changes to fix that difference. So let's say we go and we delete one of the pods here. So we do kube control delete pod and one of the 3 instances. And then we go back and we look at the pods. We can see that Kubernetes already brought up another instance of that pod. So now I'm going to show various ways that we can actually update existing deployments. So the power of a deployment isn't just in launching it once and then Kubernetes maintaining that state. It's also really nice for if you want to change the desired state. Kubernetes will like slowly make that change in your cluster. So the first thing I'm going to do is the kube control scale command. So this will just change the desired scale of the deployment, and it's a pretty simple command. Let's say we want to change the number of replicas to 2. And then we can check how many pods we're running again with kube control get pod. We can see that Kubernetes scaled down to only 2 instances of the pod. So another command that we can use that's a little more powerful is kube control edit. So let's say we want to do kube control edit deployment Nginx. And let's say we want to change back the number of replicas. So we can see that this is very similar to the original manifest that we launched. So once you do kube control create on a manifest, Kubernetes actually stores the contents of that internally, and this is what it uses to track the state of this resource. So if we go to replicas, let's change this back to 3 and then exit. We can see that Kubernetes is aware of that change, and then when we do kube control get pod, we can see that it's back to 3 now. So we can actually change various things here other than just the scale. So to demo that, I'm going to use a third command, which is kube control apply. So kube control apply is very similar to kube control create, except it's a little more powerful. So if you tried launching this deployment again with kube control create, it's going to give you an error saying this deployment already exists. So what kube control apply does is, if it doesn't exist, it'll create it. If it already exists, it'll update it to the, it'll look at the differences and make updates to it. So let's open up our deployment again. And let's say we want to upgrade one of the containers in one of the pods. So let's say instead of Nginx 1.12, we want to update to Nginx 1.13. So we made this change to the manifest, and then we can do kube control apply. And then now behind the scenes, Kubernetes is actually going to be working to apply these updates to the pods. So if we do kube control get pod again, we can see that all of these 3 pods here are different than the last 3. So the process that Kubernetes uses behind the scenes to update a deployment is to delete existing pods and then recreate them one at a time. So let's just exec into one of these pods to see the version. Okay, so we can see that it successfully updated to the newer version of Nginx. Okay, so the last command I want to talk about in regards to deployment is the kube control run command. So this is a pretty basic command too that just starts a new deployment without like a manifest file existing. So if you want to just take a Docker image and you want to run it in a cluster, this is a pretty easy way to do that. So let's say we want to do kube control run like a second instance of Nginx. We could do kube control run Nginx to, let's say we want replicas equals 3. We also need to specify the image name too. Okay, so this creates a new deployment. And again, we'll see all these pods being created after the fact. So lastly, I want to talk about another command. We've been using kube control get prior to this, but there's another really nice flag on it that's pretty powerful. So if we do kube control get deployments, it doesn't really matter which deployment in this case. I'm just going to use Nginx 2 as an example. And then we add the -o flag. We can actually export the current state of this resource within Kubernetes and see what it looks like. So we can actually see that when we did the kubectl run command, Kubernetes behind the scenes actually created a resource for us. And then this is actually viewing or exporting the current state of that resource. So if you ever do like kubectl edit, and the actual state of your what's in Kubernetes is like not in sync with like the files that you have locally, you could always do kubectl gets -o to export what the current configuration is and see what the difference is between what's actually running and what's on your disk. Okay, let's switch back to slides to talk about services.
I'm just going to interrupt real quick. So I saw a bunch of questions. I know we've been answering them a lot, so I don't know how easy it is to follow along the answers. I know one big question has been about, what's it called? The hosts. So right now in our setup, we only have one host in Rancher, so you can actually have hosts. Share my screen. You can have hosts. You can add a host basically across different clouds. This is just basic Rancher concepts that a couple people have asked, so I just want to touch base on it real quick. You can add hosts across different clouds. What happens is our networking actually creates an overlay networking so that all the containers that are deployed can communicate with each other. They can be in different geographical regions is what I've seen, different cloud providers, different locations. So as long as you have, there's usually some, depending on your networking choice, there's some ports that we require to be open to allow that networking to work. But otherwise, you don't have to stick to one provider and you can use it across. With that being said, the only caveat I would say about that is that for Kubernetes, if you are a more advanced user of Kubernetes and you're using a specific cloud provider, you would obviously need to use that cloud provider for your Kubernetes setup. Okay, I'm going to then go back to the slide.
Okay, so something that I didn't touch on when we were doing the slides about deployments earlier, like a lot of people, you might have seen earlier Kubernetes tutorials and you might have seen the concepts of replication controllers or replica sets prior to this. And I would say in general, you don't actually have to worry about these concepts. These have largely been superseded by the concept of deployments. So these are like two things behind the scenes in Kubernetes that are actually managed by deployments now. So you probably wouldn't want to launch either of these two things directly in your manifest file anymore. You'd probably want to launch a deployment, and then a deployment handles all of these things. Okay, so the next concept I'm going to discuss is a service. So services can be used to create a DNS entry to refer to a group of pods in a consistent way. So earlier we launched like all these various pods that are managed by a deployment. So now if you have another like microservice in your cluster that you want to access the service, I think the service abstraction in Kubernetes is the correct way to do this. So when you launch a service, it's going to provide a DNS entry and provide a consistent endpoint for other pods in your cluster. So a service can be thought of in some ways as a load balancer. So you only need to know of the existence of the load balancer, and behind the scenes, you don't need to know the IPs or anything like that of the other pods. Okay, so let's do a demo of services.
Switch back to Josh real quick. I think I switched it to you.
Okay. So I'm going to be launching a pretty simple service manifest file that makes use of the earlier deployment that we launched. So we can see that there's a lot of things in common again, like metadata and things like that. So the selector here, this is actually what determines where the traffic is routed to. So in the earlier example, we had the label on the deployment, and I was saying we'd come back to that. So the way it works is when you launch a deployment and you add a label to the pods, each of those pods is managed by the deployment is going to get this label. And then when I launch the service that has a selector on it, this selector is going to determine pods that have this label should have traffic routed to it. So in this case, any pod that has the label app with value nginx should have the traffic routed to it from the service. So if you look at the port section, we can see we're getting routing traffic from port 8080 to 80. So port 80 is the one that nginx listens to by default. So we're getting routing traffic from port 8080 to 80 and also from 80 to 80. So we can create the service with kubectl create. We could have also done kube control apply as well. Okay, so you can see that the service was created. So now if I go back to the shell that I launched earlier, so remember this is a pod that was inside of the cluster. We can try to access the service and see if we have access to it. So the domain that you would use to access the service is the service name .default.svc.cluster.local. So this last part here, the service.cluster.local, that part is always going to be there. The default isn't always going to be there, but to discuss like where this term comes from, I have to go into namespaces, and that's something I probably don't want to cover today. So if we're running in the default namespace, which is the case for all this demo, this is going to be the domain that we use. Okay, so you can see that the service routed traffic to one of the pods. So we don't actually know which pod the traffic was routed to, but since they're all replicas of the same thing anyways, it doesn't actually matter which one we hit. So this one did it on port 80, and we also routed traffic from port 8080 as well. So let's try doing a curl on that. We can see the same thing here. So
one quick question that has come up, I see a lot of is kind of, I know it sounds like some people have heard of ingresses, and I know we're going to cover that in a little bit, but they want to know what the difference between a service and an ingress is, since we've kind of described a service kind of like a load balancer.
They're actually pretty similar. Service is mainly for internal traffic, so services that are running inside of your cluster for communicating with each other. And then the ingress is how the traffic from outside the cluster is routed to services inside the cluster. So ingresses are basically a way of exposing those services to the outside world.
Okay.
Yep, so let's go back to the slides to discuss another concept.
Oh, one person did ask, Philip Alberg, who loves to come to our training sessions. He wants to know if you would recommend services or ingress controllers.
I would say probably both. So you can, if you're on a cloud provider that supports load balancers, you can use a service to expose traffic inside the cluster. So it depends on your use cases, but yeah, it would just depend on what your use case is. But services is always going to be used for inside, and ingress is always going to be used to expose those inside traffic. So you could also do it with a service, an external service, but we're not going to be actually discussing that today. And if you're on a cloud provider that doesn't support load balancers, you have no choice but to use the ingress controller then.
Okay. Am I taking back the screen? Is that?
Yep. Okay, so the next topic I'm going to discuss is the topic of config maps. So these are a resource that you can launch in Kubernetes that allow you to store configuration values and configuration files. So once you create these resources within Kubernetes, you can put these inside of pods in two different ways. You can expose them as environment variables, or you can expose them as local storage. So you can either create an environment variable when you're launching a pod, or Kubernetes will mount a new directory inside the pod when it's launched. And then I'll show a demo of this speed up. Okay. So the first thing I'm going to launch is the actual config map resource itself. So this was created prior to launching any pods or deployments that make use of this config map. So let's take a look at this. So you can see the config map has a data key, and then under the data key, it's just an arbitrary key value map. So each key and value within this is going to be stored within Kubernetes itself once we launch this. So Kubernetes is going to store this data inside the etcd cluster. So it's going to be persisted once we launch it. So we're going to create a simple config map that just has a key 1, key 2, and we're going to call it testcm. So we can create this with kube control creates. And we can see the config map was created. So let's just do kube control gets -o to show the contents of it that are stored inside of Kubernetes. Okay, so we can see that this came from Kubernetes itself, so these values here are actually stored inside of Kubernetes. So now once these are launched, we can actually expose these two pods that we're going to launch. So first, let's demo launching these values inside of a pod as an environment variable. So this is another pretty simple container here. It's just Ubuntu, and the command is sleep infinity. So once I launch this, I'm going to exec into it, so I just need some command to keep it alive. And then under the environment section, you can see that we're going to have two environment variables. We're going to have one called primary key, which just reads from the testcm config map, and it's exposing key 1. And likewise for secondary key, it's just going to be coming from the value for key 2. So let's launch this deployment. Or sorry, let's launch this pod. It's just a pod. So you can control get pod. You can see that it's running. So let's try execing into it and see what's in there. Okay, so if we type env, which just shows the current environment variables, we can see that there's the primary key, which has value 1, and secondary key, which has value 2. So if you're launching an application where it's configured via environment variables, it might be very helpful for you to store these type of keys in a separate resource independent of the deployment. So like, let's say you had 2 different deployments, each that use a similar set of environment variables. You could create a config map ahead of time so that you don't have to duplicate this configuration inside of each of the deployments. Okay, so the next pod is actually going to be like exposing these config maps as a directory inside the pod. So it's pretty much the same as the last one, but rather than exposing it as an environment variable, we're going to see that we're defining a volume called config volume, and the source of that is this config map called testcm. And then we're going to mount that into the pod into the container as etc config. So let's create this pod. And then let's exec into this pod. Okay, so if we go to the etc config directory, we can see that there are 2 files in here. There's key 1 and key 2. So for each key in a config map, we're going to get a file name or a file, and then the contents of each of those files is going to be the corresponding value. So in key 1, we'll see value 1, and then in key 2, we'll see value 2. Okay. So now I'm going to show kind of a putting together the last couple of resources type of demo, and I'm going to show another way we can actually create config maps as well. So for this demo, I'm going to be launching nginx, but instead of launching the default configuration, I'm going to be using a different one. So default.conf, this is an nginx configuration file, so if you're not familiar with the syntax at all, that's fine. We're just going to use this for this one demo. So this nginx configuration file is just going to act as a proxy to rancher.conf. Okay, before I launch this, I'm just going to open up this browser page and discuss the nginx container for a moment. So a lot of times when you see on Docker Hub, when you're launching an image, a lot of different applications require a file from like local disk as configuration. So for nginx, for example, it actually is going to read configuration files. So like the way that nginx recommends doing this is by bind mounting a file from the host. So when you launch this container, it's just going to grab a file from the host and mount it into the container when it's run, and then that file is mounted over the file system that you get from nginx. The problem is when you're launching this to a cluster system like Kubernetes, there's no way to ensure that this file is actually going to be on the host. So this is like where config maps come in. If you have like an application that requires configuration inside the pod itself, you don't want to actually bake that into the container image. It's kind of inflexible. So let's say you wanted to launch nginx in your cluster, you'd rather use the upstream nginx image rather than having to do like from nginx and then copy it some kind of configuration and then ship an application. Like the release process for that is just a little bit slower than managing this via Kubernetes. So in this case, this is exactly what I'm going to do. So inside this deployment, actually I'm going to create the config map based on this file first. So rather than just doing this as like a raw manifest, I'm going to use the kubectl create command. So if I do kubectl create config map, we can see that we can actually take an existing file and then just directly expose that as a Kubernetes config map. So now let's do kubectl get on this and see what the contents are. Okay, So we can see that the default conf file was actually created here, and it's being stored by Kubernetes. So now I want to use this inside of a deployment where one of the pods is going to be running Nginx, and it's going to have this config map mounted inside of it. Let's check out this proxy deployment manifest file. So it's a pretty simple deployment again, 2 replicas, and it's going to be exposing this proxy CM config map volume into the directory etc nginx const.d. So this is the directory that Nginx is set to read from by default whenever you launch it. Okay, so let's do kubectl create on this. Okay, so you can see that the deployment was created. So now, once the deployment is created, behind the scenes, Kubernetes is creating these pods. So now I want to expose this as a service to this cluster. So the proxy service is just going to be routing traffic from port 80 to port 80. So I'm just using this to give a DNS name to these pods. All right, so let's create this service. And then we can do kubectl get services to see that it was created. Okay, so we have the proxy service now. I'm going to go back to the shell that I launched earlier. So rather than doing a curl on the Nginx service, I'm going to curl our proxy service. Okay, so you can see this is a bunch of HTML that's being grabbed from rancher.com. I can actually do a web browser to show that this is actually truly is rancher.com. Never mind, I guess it's not set up correctly. All right, anyway, so it did route traffic to it, and it is proxying rancher.com. Okay. So now we have this proxy running inside the cluster. Now let's move on to like another concept called ingress.
Let me just take. Okay, so I know we've had a lot of questions. A couple of things that I will cover after Josh is done. So he's, I think, going to cover ingress next. Are you going to actually deploy an ingress and explain how it works? Okay. And then I know there have been a couple questions because obviously most of this demo has been using the CLI. I'm just going to show how you can access the dashboard UI through Rancher, what it looks like, and just give a quick overview of it. I know there have been questions for that. Let me just take back presentation. Okay.
Okay, so the last concept I want to discuss is ingresses. So I already talked about this earlier a little bit. So this just defines how traffic outside the cluster can access services that are inside the cluster. So when you have Kubernetes clusters or services that you've already launched, you want to expose these to the outside world some way, and you want to control how they're accessed. So you can route traffic to these services in various ways or through various configuration things. So you could do it based on the host that's being accessed, based on the path, and a couple of other different factors. So I'm going to do a quick demo of ingresses on the existing app that we just launched.
Do you want to talk a little bit about like how the ingress controller works in Rancher and what we launched? Or are you planning?
Yeah, sure. So behind the scenes, the ingress resource that you launched is actually going to be managed by Rancher. So Rancher is going to be listening to these events and then creating Rancher load balancers behind the scenes to actually route this traffic. So the Rancher load balancer is based on HA proxy, but you don't actually have to use the Rancher load balancer. If you wanted to, you could deploy a different ingress controller. So if you wanted to run like Nginx to route your traffic, you could do that as well.
Okay. I gave you a presentation, right?
Okay. So the ingress I'm going to launch, it makes use of the earlier app that we just launched. So the first thing I want to discuss in this file, it's kind of a new concept, is just having 2 different things within the same file. So up to this point, we've only launched 1 resource per file, but if you would want to launch 2 just for convenience, you can put a triple dash and then have 2 separate areas of your YAML file. So the first ingress that I'm going to launch is an ingress for our proxy. So the annotation here, HTTP port, this decides where the load balancer is going to be listening on, or which port. And then the backend is just telling us which service this traffic should be routed to, and then which port it should be routed to. So since this proxy service was created in the last step, and we decided that we were going to expose this on port 80, we want to route traffic to port 80. And so the next thing we're we're going to be routing traffic to the Nginx service, which we created the very first step when we were demoing services. So rather than listing in port 9000, we're listing in port 9001, and then also routing traffic to port 80. Let's do kubectl create on this ingress. Okay, so we can see that the ingresses were created. Let's do kubectl get ingress to see what the current list is. So this gives you some pretty helpful information to see like what the current status of its ingress is and like how it's routing traffic. Okay, so if I go to the actual IP of the host itself, we'll see that it's now routing traffic from here inside the cluster. So first let's do 9000. So we can see this is actually routing traffic to the service proxy, and then the proxy service is going to be routing traffic to some pod that in turn is proxying rancher.com. Then on 9001 we should just see, on 9001 we should just see the basic Nginx web page. Okay. So there are various other ways that you can configure ingress resources. So in this case, I'm only going to demo the basic ones, which is just routing from port to port. But you could also decide based on path name and other factors as well.
Yeah, on the doc site, we do list out all the different kind of, I think it's usually in the annotation that we put it in, of how you want your ingress set up, where you can do hostname path routing. I think if you're familiar with Rancher concepts, you can specify where you would want your load balancers, which host you would want it to go to. All those concepts do exist on the doc site under Kubernetes as well.
Do you want to do dashboard?
Yeah, or why don't you can do it since you're sharing instead of me taking it again.
Sounds good. Okay. So if I go back to the Rancher UI that we had up earlier, so instead of CLI, if we go to the dashboard page, we can actually launch the upstream Kubernetes dashboard, which is just a nice GUI that can be used to interact with the cluster. So like a lot of the workloads that we discussed already, like deployments and pods, we can see everything here as if we did kubectl get for each of these resources. And then it shows some like other metrics as well based on like CPU usage and memory usage. So if we go to the create in the top right, we can do, this part here is basically the equivalent of kubectl run. So this is going to be creating a new deployment based on various configuration things. And if you click on show advanced options, you can control other things about the deployment as well. But the more powerful general part is the ability to upload or paste a YAML file. So everything we've launched so far, we could have just pasted or uploaded here, and it would have launched it through the dashboard as well. That's about it.
Okay. Are there more?
Nope, that's the last slide.
Okay. So I'm looking at the questions that are trickling in. I know one of the main ones that have come in that is basically the difference between cattle and Kubernetes. Which one would you recommend, or other various comments or variations of that question have come in. So at Rancher, we're kind of, I call it container orchestration agnostic. If you want to use cattle, we'll support you there. If you want to use Kubernetes, we'll support you there. It's really more up to what you want to do and what you're comfortable of how you want to approach orchestrating your containers. So that's kind of my spiel on what the difference is. I mean, I think as you play around with it, that's up to you to decide which one you would prefer more. I don't think currently Josh has anything else to demo specifically. I just have a couple more things of slides, but then you guys could ask some questions and then we can see if there's anything else we want to demo. I think everyone can see my screen. So we do have our Rancher user Slack. There is a Kubernetes specific channel in that Slack, so slack.rancher.io. If you want to come and join, you can ask questions about your Kubernetes setups, about Kubernetes itself sometimes. I think there's a fairly active community on user Slack. We just want to say thank you for attending. And then also, if you want more information about deploying and scaling Kubernetes with Rancher, you can download our ebook. A couple other questions. Someone had asked, you know, if they could get the slides. I don't know if we will provide the slides specifically, but this training is being recorded and we will upload it to our website like all of our trainings, so you can go there to be able to review it again.
And
then that's all the actual.
Yeah. And at some point, I'm going to upload all the manifest files that I've showed so far to GitHub or somewhere, and we'll release those as well.
Those are all the specific slides I have.
Yeah, maybe we can just answer some questions here.
Let's see if there are any specific questions that we can answer. Okay, there were a couple questions, I think, about the ingress, about the ports. It looks like, I think they're probably, from just quickly glancing at the unanswered questions, we do have some people who are helping us answer questions about the ingress. How does it, one person asked about specifically in the file why some ports were quoted and some aren't.
So the quotation thing is mainly just a YAML file. Like, you don't actually have to quote them in this case. I generally put quotes around a lot of strings because certain characters within YAML can cause problems. So, like, if you have like colons and then happen to have a space after it, like, they would confuse that with the map syntax. So I tend to be on the safe side and just put quotes around as much as I can. But there's not any good reason for it in this case.
It looks like one question is, how is the traffic routing to the pod if you're using an ingress?
So the way that Rancher would do it is we would launch a load balancer container that would be bind mounted to the host, and then the traffic would go through that load balancer to the internal DNS, and then that would be routed through Kubernetes to the pod.
So the load balancer that Rancher does deploy is like backed by HA proxy software. I know there's some questions about, you know, if we want to use a different load balancer. So we have seen that in the past where people want to use different ingress and ingress controllers. Currently in our current template, the way to do that you would actually just delete or stop the ingress controller service that's in the Kubernetes stack, and then you would be able to use your own ingress, and that would be able to work. In the next version of Kubernetes, so right now we're demoing Kubernetes 1.5.4. We are working on our Kubernetes 1.6 template, which will add in some additional features that Kubernetes 1.6 supports itself, like RBAC. We are going to be able to have a configuration option which would allow you to disable the ingress controller from the beginning, so that if you wanted to use a different one, you could select that when you launch Kubernetes. Let's see, it looks like a lot of people want the link to the ebook, so let me grab that and share that into the questions part. I assume there's a handy link somewhere on our website as well. It looks like if you go to info.rancher.com, maybe that will help you. But let me paste that in to everyone.
So there's another question I see here. Are you going to cover HA for Kubernetes? So that's not something we plan on demoing today. We were trying to keep the tutorial within the scope of just showing Kubernetes concepts itself. We have been thinking about doing another training exclusively for like the management plane of Kubernetes itself. So like deploying like an HA Kubernetes cluster, upgrading like HA Kubernetes cluster, but we don't really have the setup to do that today.
Okay, let's see. Sorry, there's a lot of questions, so I'm just trying to field through what to talk about. Let's see. For Kubernetes 1.6, we don't have a current target release date. It'll probably be in the next, I think, couple weeks. There are some moving factors that it depends on, specifically whether or not we would want to, I can share with you whether or not we want to, how we want to upgrade from our 1.5.4 to Kubernetes 1.6, and we're going to switch from using etcd v2 to etcd v3 plus etcd operator. And so that upgrade is something that we are just trying to figure out what is the best path forward to make the experience as smooth as possible. I know someone asked earlier, now that I think about how do you upgrade between Kubernetes versions. So the Kubernetes, this is a Rancher concept, not Kubernetes, where we have Kubernetes templates, and what happens is when we launch a new version, we will release it. A lot of times, more recently, some of the Kubernetes versions, the next one I know specifically will be tied to a specific Rancher release, just because there's some back-end components that need to be updated. But usually what happens is when we push out a new template, you will see, let me see if I can share my screen and grab Under the infrastructure stacks, you can see all these little up-to-date things. Usually when a new template comes out and there's an upgrade available, you can click on it. You can click on it when it's up to date, and you can select which version you want to upgrade to, and then you can just push launch, and it will redeploy everything. You'll get into an upgraded state for your whole stack. You can kind of check it out, make sure it looks good, and then continue with your upgrade. That is, I know, one of the questions that someone asked earlier. Let's see. I know it's almost 2 hours, so obviously if you have something to do, work to go to, please feel free. As I said, we are recording. I think after the webinar, usually you might receive an email about the link to this training. If not, it is on our website.
So I see one question about having traffic as available as in load balancer option. So there is a independent traffic ingress controller that you could deploy to Rancher. I don't see it nearly as commonly used as the Nginx one, but that could change in the future. I'm not sure if it's due to stability or for what reason, but if you were interested in using it, you definitely could deploy that deploy that ingress controller to Rancher.
So someone asked, Omid asked, is there a higher Docker version that's supported for Kubernetes? So that is actually not a Rancher restriction. That is a Kubernetes restriction. So even in Kubernetes 1.6, they have not added support in for Docker 1.13 or above. So until Kubernetes actually supports that, we do not. But Rancher itself does support being able to have hosts that have higher versions of Docker. It's just that if you launch Kubernetes on it, it will not work because Kubernetes does not support it.
At the same time, each version of Docker, like the newer versions, if you're running Kubernetes, you're not going to get much value out of like constantly upgrading your version of Docker. So most of Kubernetes goes around like a lot of the Docker concepts, so it doesn't use its networking. It's pretty independent of the Docker version. So if you're like trying to consider whether or not you should upgrade to like the newest Docker version, I would just check out to see what features you might actually get out of it if you're running Kubernetes, because it might not be worth it.
Let's see. Okay, there's a couple more. So one is, someone asked about the Docker EE roadmap. So at DockerCon, I know we announced a partnership with Docker on being able to support their Enterprise Edition. I think that's available now in terms of if you wanted to sign up for support for Docker Enterprise Edition with Rancher. I would have to double check with my marketing team and my sales team. But I think if you are interested in that, Steve, feel free to reach out to me. Anyone, if you ever have any questions specifically, you can try and reach out to me either on Twitter or you can email me. My email is just denise@rancher.com, and I can try and forward your information to the appropriate parties. Let's see. Okay, one is where, I'm not really sure. It says where to check the logs related with Rancher communication. I'm not sure if what you mean for logs in terms of that, if you're talking about the logs of how the containers talk to each other, or how Rancher talks to its hosts. There's probably a couple others, I think. What would you guess on that one?
You guys have to see like what kind of logs in particular you mean. I mean, there's logs for each of the Kubernetes components themselves, so you can see like the status and output of those and various other logs too.
Okay. I think that's like, there are some questions, there are a lot of questions I don't think we were able to answer. I mean, you guys have been, there have been a lot of questions that have been coming through, and we've been trying our best to keep up with it. If there's anything that we didn't answer today, please feel free to email me, denise@rancher.com. I can definitely forward your request to someone else. Otherwise, we always recommend, if you have questions, ask our community, go join Slack, ask in the forums. People are very active there and can help you.
And if you guys have any feedback about the content of the presentation, like if there's something you didn't see that you wanted to see more of, feel free to post it in Slack or email us as well, and we'll try to fix that for another Kubernetes demo.
Okay, so I probably will I don't think we're going to be showing anything else. I'm going to drop from the audio. I'll probably stop the recording, but we'll stick on for a couple more minutes to help try and answer the questions through the GoToWebinar, just to finish up whatever is left open. And then everyone have a great day. Thank you so much for joining us on our first training for Kubernetes. Hopefully we were able to answer most of your questions and give you a better insight on how Kubernetes works in Rancher.